This is lesson 7.12, using trig ratios, applications. So what you're going to see in this lesson are word problems associated with using trig ratios. So why would we use regular trig in a word problem to find a side? Why would we use inverse trig in a word problem to find an angle? All that kind of stuff. So let's look at some examples. First, let's just say what are the three trig ratios? I'm going to write sine is opposite over hypotenuse. So, right, SOH. So cosine is adjacent over hypotenuse. Sorry, my A didn't look like an A, so I'm rewriting it. All right, cosine is ka, A over H, and then TOA is T is O over A. Tangent is opposite over adjacent. All right, let's try some problems. Actually, before we do so, let's talk about what an angle of elevation is and an angle of depression. I'll tell you, this one is typically easier for people to grasp, and angle of depression is a little tricky. So angle of elevation, let's say this is you right here standing at point C, okay? And you're originally looking straight in front of you at something over here, and then you look up into the sky, and now your eyes are going over here, okay? That, what I just highlighted, has created your angle of elevation. It's the angle your line of sight makes with a horizontal line. So that's this right here. That's the angle of elevation. An angle of depression is a little different. It says when looking down at an object, it's the angle that your line of sight makes with still a horizontal line. Notice that this doesn't change. It's always created with a horizontal line, not a vertical line. And I say that because, let's look over here. Let's say you are standing up here this time on a point like up on the top of a building, okay? And again, you are at first looking straight out. This is the best way I can remind you of doing this. You're looking straight first. You're not looking up in the air. You're not looking down at something on the ground. You're looking straight, horizontal. And then you notice something down below. So now you're looking down here. That is your angle of depression. So notice it's actually not inside the right triangle. That angle of depression is outside of the triangle. Super important that you notice that, and as we do some examples with it, I think you'll see why I'm stressing that right now. So let's take a look. All right, so we're going to do some application problems. To be honest, I'm not a big fan of this first one. I'm going to actually move this up and just kind of look at this roller coaster one to start off with here. You are at the top of a roller coaster, 100 feet above the ground. So here we are. You're at the top of the roller coaster. You're in your little cart right here. There you are. You are 100 feet above the ground, which means that this is 100 right here. You're 100 feet off the ground. The angle of depression is 44 degrees. We're going to get back to this. About how far do you ride down the hill? So once you turn and you fall, I hope you don't fall, ride down the hill right here, that's what we're asking is how far are you going down this hill right here? So this is X. Okay, now if we knew how far this was, we could use a squared plus b squared equals c squared and find that out a different way, but we don't know this. But we do know the angle of depression is 44 degrees. Now remember what I mentioned on the previous screen. Angle of depression is found if you looked, and I know this your head is a little higher than the actual point on the triangle, but we'll ignore that. If you are currently looking straight out from that roller coaster, you're looking that way. Okay? And then you look down towards the bottom of the hill. Now you look down this way to get to here, right? This is your angle of depression, and that is 44 degrees. Now, like I mentioned, what happens here is that means that angle is not inside the triangle that we're trying to use trig to solve. Okay, this angle is outside of that. So there's two ways you can deal with this. First, if you know that this angle right here is 44 degrees, then what you can do is realize that this is a right angle and therefore these two angles are complementary, which tells us that this angle is 46 degrees inside the triangle. 46 plus 44 is 90. So if this angle is 44, this angle is 46, and if I put that 46-degree angle in here, now our right triangle has an angle measure, and we can use that. That's what I would do. Now here's a different option. Okay, so same problem, same situation. We have a triangle, and we know this is 44 degrees. What you could do is you could draw from this point down here up to here, and we still know that this is x, and we now know that this is 100, and now we can use this triangle that wasn't even drawn in our original problem. I don't like that way as well, but use what makes sense to you. So now what I'm going to do, finally just get to the actual trig here. I'm going to put my right angle here with the ground. This is 100. How far do we ride down the hill? Goes here. This is 46 degrees. Again, not 44. That was outside the triangle, but 46. Now, if we know an angle measure, and we know a side, and we're trying to find a side, we can use trig to solve the problem. I'm going to label this as my hypotenuse, adjacent and opposite. Here's opposite. It's across from the 46-degree angle. That's our reference right there. And then this is adjacent. Okay. Now, I'm trying to find this, the hypotenuse. I know this, the adjacent. Which trig ratio uses hypotenuse and adjacent? Well, adjacent and hypotenuse is cosine. So cosine of 46 equals adjacent, which is 100, over hypotenuse, which is x. Again, adjacent was 100, hypotenuse is x. Now, we've learned inverse trig. So we have to think for a minute, what do we do when we have cosine of 46 equals 100 over x? Well, cosine of 46, I can do that on my calculator. I can compute this, which means I don't need to use inverse trig. I can use regular trig. I'm going to put that over 1. I'm going to cross multiply 100 times 1 and cosine of 46 times x. And then we're going to solve by dividing by cosine of 46 on both sides. Cancel, cancel, and x equals 100 divided by the cosine of 46. Again, some of you learned to compute that cosine of 46 into a numerical value. That's fine if you're doing that. But what you'll end up finding is that you are writing 143.956 feet down that roller coaster. Makes sense. The hypotenuse is longer than the height because it should always be the longest side. Okay, let's try a couple more. This one says a kite string is extended 18 feet when the kite is as tall as a 12-foot tall house. What is the kite's angle of elevation? All right, so let's add some information to our diagram. So first of all, it says the kite string is extended 18 feet. So let's say this is the bottom of the string, even though we can't see the person hanging on to it. So the kite string is this right here, and I drew it more straight, it's bending a little bit. Let's estimate. So that's 18 feet. That's the kite string, right? Goes to there. And then it says, when the kite is as tall as a 12-foot tall house. So in other words, the kite is at a height of 12. So from here, drop down, let's say this is the ground, even though again, based on this picture, it's not. Kind of have to use your imagination a little on these word problems. And then it says, what is the kite's angle of elevation? So we make our right triangle here, and we're wondering what the kite's angle of elevation is. So if I was standing here and I was looking this direction first, and then I looked up at the air at the kite, we're talking about this angle right here. By the way, I also didn't write my 12 over here for the height of the kite. So what you can see is we are looking for a missing angle measure, and we know two of the sides. First of all, we could find this length right here by using a squared plus b squared equals c squared, but that is not what we're trying to find. We are trying to find an angle measure. So if we're trying to find an angle measure and we know two sides of a right triangle, we are going to use inverse trig. So I'm going to write SOHCAHTOA up here, and I'm going to think about what trig ratio we are going to use. First of all, I know I can label my sides. This is the hypotenuse across from the right angle. Opposite of the angle I'm looking for the measure of, so that's the angle that we are referring to, is the opposite over here, and adjacent is here. We need a trig ratio that uses hypotenuse and opposite, that does not use adjacent. Well, that would be sine, right? So I say sine of our theta angle equals opposite over hypotenuse. That's always how we are going to start this. Now we're saying, okay, we're trying to find this x variable here. So sine of the angle that is x degrees is equal to opposite, which is 12, over hypotenuse, which is 18. Again, the way you remember if you're doing regular trig, where you're going to put this over 1 and cross multiply, or if you're going to use inverse trig, is can I find the sine of a variable? No, because we don't know what that is. So this is when we need to use the switcheroo. We're going to take this and this, and we're going to switch their places and use inverse. So we say, oops, excuse me, hold on one second. So we're going to say sine inverse, switch around. We're going to take our 12 over 18 and say that's equal then to x. Okay, now we're going to use our calculators and use sine inverse of 12 over 18 and find out what our angle is. You should check out on your calculator what you get so that you know if you're doing things accurately. You should get a 41.810 degree angle. So we're talking about a 42-degree angle of elevation for that kite. All right, now let's look at the second part because it's also about a kite. And it says you are flying a kite and have let out 80 meters of string. The kite's angle of elevation with the ground is 40 degrees. If the string is stretched straight, how high is the kite above the ground? Now let's take a look at this same triangle right here. This is our kite up here, just like in the last example, right? Okay, there's our kite flying along. Woo. Okay, so you are flying a kite and have let out 80 meters of string. What that means is from here to here is 80, because that's your string, right? Just like we saw in this example up here, that string that was hiding in the blue sky there. And then we have the angles. The angle of elevation is 40 degrees with the ground. So it tells us the angle of elevation with the ground. That's 40. Then it says if the string is stretched straight, so if this is a straight line between these 2 points here, straight segment, how high is the kite above the ground? So now we have our variable right there. Okay, so now this is still the hypotenuse. This is still the side that's opposite the angle we are referring to, and this is still the adjacent. And we're still going to be dealing with these two things because we are trying to find the opposite side, and we know the hypotenuse, and we're still not dealing with the adjacent side. So it is sine again. So this time we write sine of theta equals opposite over hypotenuse, and we're going to fill things in a little differently. So sine of theta, the angle of reference, well, that's 40. So sine of 40, which is a numerical value, is equal to the opposite side, which is x, over the hypotenuse, which is 80. Now, since we can find the sine of 40 on our calculator, you can do that right now and fill that in, or you can keep working like I taught it last unit. All right, so we can cross multiply. X times 1 is x, and then we take and multiply the sine of 40 times 80. So again, different teachers teach this different ways, but if you had computed the sine of 40 and gotten 0.643 and then multiply that by 80, Your answer will be about the same as mine, depending on how we kind of round, which is 51.423. So how far or how high above the ground is the kite? It is 40 or 51, almost 51 and a half feet above the ground. All right, well, this video is already getting pretty long. There are a couple more examples here. If you want to give them a try and then ask me about them in class and check them out, you can do that. I will put the answers on the screen so you can check your work to see that you have these done correctly on your own. All right, so here's the two answers. I am going to show you, I have a little info here. What you want to do is you want to talk about the angle of descent of that plane is this angle here, the question mark that we're looking for, which is this answer. You find that by first finding this angle inside the triangle by using inverse tangent, opposite over adjacent. Using inverse tan, you find out what this angle is. Then we can subtract this angle from 90 to find out the angle of depression or descent. So if you have questions on that one, definitely let me know.